Hello, everybody. We're going to interrupt our presentations on classes because I want to do the second thing that goes with classes in many respects, pointers. And then I will go back to more details about classes. Now, pointers are the second item that I said were the real themes of 104. In the first part of this class, we had to review what you should have known from 103, all those particular techniques of programming. Now we're getting to the new things. And the class was the first of them. And now we talk about the pointers. Pointers are used everywhere. Operating systems use them. Networks use them. Artificial intelligence uses them. They are part of the core way of doing many programs in computer science. And you have to get used to them. In fact, in 225, you'll see them all over the place. Now, a pointer is a new data type. The value in the pointer is not an int. It's not a double. It's not a char. It's not a boolean. It's not a string. It's none of those things. It is the address of another variable. Think of it as this pointer says, there it is, over there somewhere. That's what we mean. It points to another variable. We don't know the name of the other variable. It's anonymous. And the only way we can get to it is to follow the pointer to the variable. Now, why would we want to do that? Well, if we want to build more complicated data structures, they may have lots of variables in them, and we don't want to have to create lots of names. We don't even want to, and an array or a vector is stymieing. It locks us into a certain way of organizing the variables, the parts of whatever we want to create. So instead, we create anonymous pieces and connect them with pointers. Now, I'm going to illustrate this by looking at a particular data structure that I want will use this. Often in computer science, we run what are called simulations. That is, we try to have the computer imitate some real-world operation so that we can test it and see what might happen if we change the parameters in that operation. For example, if we're a grocery store, what would happen if we had one line and we put 3 cashiers on? Would that be different than having 3 separate lines for each cashier? Would people wait longer on average under one method or under another method? By using some statistical techniques, we can run simulations and see what we might expect if we were to do them in the real world. Now, to do that, we have to have ways of imitating some of the main world objects. And one of the objects in the main world is a waiting line. It can be very frustrating, I know. You might have very long waiting lines, but they're there. They're everywhere. We use the quaint term queue. I always think of that as more of a British term than an American term. But at the time, the British and the Americans were very much involved in programming, and so the word queue was the one that was used. The British are much more used to queuing up in lines. I'm not sure Americans say that much. Now, we also call it a FIFO queue, because there's another kind of queue we'll talk about later. But a FIFO queue says, whoever gets in line first gets out first. That's the kind of queue you see at a grocery store and would complain bitterly if somebody cut the line. Whoever's first in the line is the first one that's going to be served. So we use those initials, first in, first out. And it's one of two kinds of queues. The other one is going to be a LIFO, last in, last out. And believe it or not, you've already seen one of them. The stack that we implemented as a vector in one of the earlier programs could be implemented as a last in, first out queue. Now, there are three new symbols. But first, let's look at a picture. That's how I visualize it. It's not the only way I visualize it, but I think it's a reasonable way in the first run to think about it. Those pointers will turn out to be variables, and we'll expand on what we have there. Fiona will be a name, but it will also have a pointer connected to it. In this particular kind of line, the person knows who's behind them. Each person, if I take them out, if I take a person out, I can find out who's behind them. I can't find out who's in front of them. So I got to be very careful. If I remove Lily from here, well, I can find Cindy, but I can't connect it to Fiona, because Lily can't tell me that Fiona is in front of her. She doesn't have a pointer to Fiona. We'll find out later that we can fix that with what are called doubly linked lists. That is where we connect a person to both the person in front of them and behind them. Now, there are three new items we have to look at, new operators. One is the asterisk, one is the right pointing arrow, and the other is the word new. Even though new doesn't look like it, it's an operator, just like plus and times and divide and all the rest of them. When you see the asterisk, you should read it as points to. So if I have the line string star front, I should read that as front points to a string. Now I know I'm reading it from the right to the left, but that's okay. Another reading of it is front is a variable that has the address of string in it. That's saying the same thing. It says front points to a variable that is a string. We do not know the name of that string. If you want that string, you have to find a way to get front to tell you. And that way is coming up. That way is the arrow. If you see an arrow, it's read as what it points to. So if X is a pointer, then X point to is the variable that X points to. It's actually a variable. Funny looking one, strange name, but that's what it is. And it can function as such. We can put a value into it, for example. Now, since we have anonymous variables, how are we going to create them? We're not going to give them names. So the operator new is used. The second line here says, I am going to create a new variable for you of type int, and I will put the pointer to it in X. So X is a pointer to the new variable I created. C++ will use that new. It will pull out some memory from a section of memory it has, and it will create the variable, and it will put the pointer to it inside X. I guess there's one other thing I should have mentioned. I forgot to mention. If we want a pointer variable that points to nothing, we can write X equal null, where X is a pointer variable. We use this to indicate the end. If there's nobody behind me, then I should be pointing to nobody. And the way I point to nobody is my pointer is null. Notice it's capitalized, and it's a reserved word. It's just like true and false and int and all those other words we've been using. And it's used over and over and over again. Now, I wrote a little program to do this, so I'm going to go to the program now, and we'll take a look. So here's my program for a line. I'll say it's waiting in a grocery store, but it could be just about anything, anywhere where a line could be. And I put in my usual three things, and now I did something strange right off the top. I created a structure. If you remember, a struct creates a new variable type. This creates a variable type person. And I give the person two parts. The person has a name, and the person has a pointer to tell who's behind it. So when I say person now, there are two parts to it. And to get to those parts, we would say person.name and person.next. But we'll be looking at those in a little bit different way when we have a pointer to a person. And now I'm going to create my waiting line. Well, what do I need in my waiting line? It's a class. So you see, I haven't given up on classes. I'm really doing an example of a class right now, but a more exciting class with pointers. I'm going to be able to add a person. Now, I just said I'm going to add a person's name. Not adding a person. I'm adding a name, and I will create a person variable with that name. I can remove the top person from the line, and you notice I don't return it. I can look at the top person. Now here I return the full thing. I return their name and the next pointer. It is traditional in many of these queues to have two different functions. One that removes things and one that lets you find out what's there. It makes it more reasonable. That way you can look at something and then decide if you want to remove it. Now I'm also going to have getLength. Length will be a variable that is connected with the waiting line and will tell you how many persons are in that line. It will start out as 0. Then I'm going to have a print line. This helps me in debugging programs. It's really like the first thing I ought to write. It tells me I can use it to see if the rest of the stuff is working. And it's void. And now I'm going to give you the private part. I don't want the person fooling around with this waiting line. They can look at the top person. They can add people. They can take people out. They can find out how long it is. But I don't want them putting somebody in the middle of it. That would break everything. So I'm not giving them that chance. I'm telling them that front, which is a pointer to a person, is private. I will control the front of the line. And the same thing for the rear of the line. And the same thing for the length of the line. Now notice I initialized all three of these, and I also initialized next up here. That's a good thing to do. When you have variables that are part of either a struct or a class, you might want to initialize them. Now I didn't do that with person because a person is going to be read. There's no reason to initialize it. I'm going to read it in. So that's the top. Now I have to define all these things. I define one item here. Get length just returns length. So that was easy enough. I did that there. Now, as you are doing in your homework, we now have to define the various methods in this class. The first one I define is add. Notice again, the name of the class, : That means that I have the right to use front, rear, and len in this program because I'm a trusted person. I've got the wait line : in front of my name here. I'm trusted. I'm the creator, not the user of this. So what am I going to do? Well, I create a temporary person. I create a pointer to a person. And the first thing I do is create a new person. So I'm going to create this structure that has two parts, a name and a next. If you look at the declaration up here, immediately the next is going to be null. So I don't have to do that. But I do have to put a name in. And the name I'm going to put in is P. And now you will notice something strange. I didn't write temp.name. Because temp is not a variable of type person. Temp is a pointer to a variable of type person. If I want the variable, it's temp points to. So I'm saying temp points to name. Now, the people who developed C++ were not entirely consistent. It would have probably been more consistent to put a dot after that and then the part you wanted. But they didn't do it, so we had to do it. What that line says is, I am going to put n into the name portion of this new person I created. That's what I'm going to do. I'm going to create them and put in the name. Now, I want to put them at the end of the line. Well, there are two possibilities. If the line's empty, then both front and rear are going to point to them. There'll only be one person in the line after that. So I'm going to point both of my pointers to that one person. However, if that's not true, I have to add the person at the beginning. And now we start playing the games that we have to think of. I want to add a person at the beginning. There's somebody already there. Front is pointing to that. Pardon me, I want to add it at the end, not at the beginning, the end. Rear points to the current end. Well, I want to take that person who's at the end right now and point them to my new person. And then when I finish doing that, I want to change who's at the end by changing rear. So it's a two-step operation. First, I find out, well, I guess three. Who's at the end? That's what rear tells me. All right? Rear next should now point to my new person, the temp. And now I can destroy the old rear and have rear point to temp. So I've done this in 2 steps here, even though it looks like I needed 3. Rear point to next is the pointer for the last person in line. I point them to temp. They're no longer last in line. And to emphasize they're no longer last in line, and because I need to do it, I have rear point to that same person, the person who's last in line. So I have added that person to the end of the line by taking the current last person, rear. The rear pointer is that variable that is a person. It has a part called next. I'm going to have that part point to my new person. And then I'm going to say, well, rear, and I used rear, was pointing to the other person who used to be last in line, but now I wanted to point to this new person I put behind them. Now that's almost right, but there's something we might easily forget. I'll give you a second to think about it. If we were in class, I'd ask you if you could tell me what it is. Is there anything we should change? And in fact, it's staring at me on the screen right now what I need to change. Look up at the top. I initialized len to 0. It just added a person. Well, I better increase the length of the line by adding 1 to it. So that's my addition. I put a person at the end of the line. Now, I want to remove a person. Presumably, I'm sending them somewhere. All right, well, if I want to remove them, I have a special case. If there's nobody in there, that's an error. So I first check to see if the length of the line is not 0. If it's not 0, then all I do is say, okay, front used to point to you. Who do you point to? Front point to next. All right, that's the new front. You're going. Front used to point to you. I looked at front, and I found out who front was pointing to. Front points to is the person pointed at the front of the line, and next is who's behind them. So I took who's behind them and put it in front. That essentially wipes them out. Now, I had to deduct 1 because I took them out. What do I do if length equals 0? Well, I just print in a message. I won't even worry about it. Okay, now, look at. Well, again, if length is 0, there's nobody to look at. So I'll say nothing to read. Otherwise, and just because I have to return something, I return null, because that's really what it is. Nobody's there. Otherwise, I just return the pointer front. I didn't need the parentheses. Oh, that away. So that's easy. And notice I don't change len because I'm not taking them out. Now, print line. This one's going to maybe surprise you a little. I like to have it so I can tell where the Q begins and where the Q ends. So the first thing I did was I wrote front of Q. If the length is 0, the Q is empty. Now you may ask, what is this \t? But we've had a \n. The \n meant new line. You might be able to guess what \t is. \t is tab. Tab to the next place. So I wanted to indent it. And once, now I have to ask, well, if it's not, now I have to print the whole line. And I'm starting at the front. So I'm setting up a for loop. But now this is an interesting for loop. The index is a pointer to a person. And the index begins at front. Well, I can't very well go front plus plus as the way to go to the next place. So instead I say, well, int is pointing to the person I just printed out. Now I'll have in point to the person behind them. So ind will be the person I just printed out, and the points to. Who do they point to? And how do I stop? Well, if I get to the end and I printed out the last person, then their next should be null. So I keep going as long as I don't have a null. So this is not the typical for loop we've been using. It says start at front. After you print the person, go to the one behind them and keep going until there's nobody else, until you get a null. And what do you do each time? You print out their name, and I did a \t again. And then whatever I did in either case, afterwards I print end of Q. Now I think that's it. Oh, string input. Well, I'll go down. Input was going to be very simple. Let me get rid of all this stuff. Input is very simple. I read a person's name with the get line, and I return it. So all it does is read a name. And I've set it up so it could read a full name with a full line. At least I hope it does. Now let's look at the main line. I just wanted to test it. That's all I wanted to do. As with a class, you have to declare an object of that class. I chose W as the name, so W is a waiting line. And the first thing I did was print the waiting line. That better come out that the queue is empty. Then I decided to read in 5 people. It was easier to use a for loop than to keep writing them out. So I read a person in and then added them to the queue. Remember, I read the person's name and added them to the queue. Then, if there's somebody in there, and there will be, I'm going to find out who it is by w.lookAt. Remember, that returns the person, the whole thing, both the name and next, and I want to print out the name. Then I decided to print the line so you could see what it looked like. Then I removed 2 people. and printed the line again to see if it removed the first two people. So let's run it and see how it works. So the first thing is, as expected, the queue is empty. So I'll put Albert, George, Mary, Sue, and Marge. Now, if I'm correct, the queue will start with Albert and go down. All right. You notice that I have a line here that says the next in line is Albert. He's at the front of the queue. Then I removed two people. The two people I removed were Albert and George. Now Mary's at the top of the queue. So it worked. At least it seemed to work. Now, that's a very quick introduction to the idea of pointers. I'll be giving you a project involving pointers as soon as I can decide which one I want to give you. The one I gave to the class last year, I don't want to give again. It didn't really work the way I wanted it to. So I'm going to think up a better one, I hope. So here's the output I got. And now I'll copy the program for you. And this will go out, and I'll post this. So good luck. And again, if you're just coming back from Easter or Passover, I hope you had a very good time, and you're rested for the rest of the semester. We don't have an awful lot of time, but we have some. So let me put that in there. And that's it. See you later.